Hey, welcome back to Banana Math, a ridiculous channel where I try to teach you basic math concepts while wearing a banana costume. Today we're going to be talking about order of operations. Hey, that brings a joke to mind. Two friends are at a restaurant, they both order banana, but there's only one left. How'd they resolve the problem? Nothing to resolve here. What's a banana between friends anyway? It's just a banana split. So, order of operations. What we want to learn today here is, let's say we've got a string of operations and we need to know in what order to resolve those operations because, as we will see, if we do them in different orders, we will get different answers. And the answer is this simple little acronym PEMDAS. That's going to help us a lot to decide what order to do things. The first thing we're going to look at is parentheticals. And we're going to do some examples and see more what we're talking about. Now, technically speaking, parentheticals are not themselves standalone operations. They're just used to denote when we should do something before something else. The next thing we need to resolve are exponents, and that's things like a to the x. The next thing that we resolve is multiplication and division. And by convention, there is no priority here. The only priority is if we have a string of operations that include multiplication and division, we're going to do them in order from left to right. Last thing that we do, addition and subtraction. Same thing here as with multiplication and division. The other thing we want to remember, hey, we got to do these from left to right if we see them in a string. So, like I said, PEMDAS is the acronym we want to remember. Parentheses first, exponent second. Third is multiplication and division. We do that from left to right. Last, addition and subtraction. That's our fourth operation. We're going to do that from left to right. So let's jump into some examples. Okay, so before we jump into examples, I just want to briefly talk about what is an operation. And simply put, it's a function that takes zero more inputs and returns an output. And what does that mean? Well, let's say we have an operation O. And we have inputs, maybe I1 up to IN. We call these inputs operands. And it's going to return some kind of output. And we'll call that output, I don't know, Y. That's what an operation is. Today we're going to be talking about the operations that you normally think of in relation to some simple math, but there are operations outside of multiplication, exponentiation, division, addition, and subtraction. But today we're only going to be talking about those types of operations, and those types of operations are called binary operations because it takes two inputs. For example, multiplication, it takes 3 and 3 and returns the output. Alright, let's jump into some examples. Alright, we're ready to tackle our first example here. And we're just going to use our acronym PEMDAS to help us determine what order we need to do these operations in. So we're going to run through it. I don't see any parentheticals. I don't see any exponents. I do see multiplication. So we're going to start there. And we're going to start by doing 9 times 2. 9 times 2 is, of course, 18. And then we're going to write the remaining string of our operations. All that's left is, of course, addition and subtraction. And as we learned on the last board, we do that in the order from left to right because there is no priority between addition and subtraction. So we're going to go with the leftmost operation, 18 plus 3, and complete it. We get 21. Add on the remaining string. We're going to now do 21 minus 4 next because that is the leftmost operation. We get 17 minus 2. And finally we finish this off by doing 17 minus 2, which is of course 15. So you might ask, well, why does this matter? Let's try to do it in a different order and see what happens. I'm going to do, I don't know, let's pick a random one. Let's do 2 plus 3 first and see what happens. I get 9 times 5 minus 4 minus 2. Next, let's do the multiplication. 9 times 5 is 45. Minus 4 minus 2. Let's do this operation next. 45 minus 4 is 41. And minus 2. 41 minus 2 is 39. And this is the wrong answer. We did it in the wrong order. So now you can kind of get a sense as to why the order matters. All right, here's our next example. We've added kind of all the operations plus a parenthetical. And what we want to do is just use PEMDAS, the acronym, to kind of determine what order we need to resolve each of these operations in. So let's jump into it. Parentheticals. Do we have a parenthetical? Yes, I've got a 1 plus 3 contained in the parenthetical. So let's go ahead and resolve that operation first. I get 2 cubed times 4 divided by 2 plus 2 times 2. Okay. Do I see any exponents? Yes, I do. I see a 2 cubed. So let's go ahead and resolve that next. We get 8 times 4 divided by 2 plus 2 times 2. Continuing, let's see what we have next. We definitely have multiplication and division, and just like we talked about before, there is no priority. We're just going to work from left to right. Let's do with this leftmost multiplication. 8 times 4 is 32. We get 32 divided by 2 plus 2 times 2. Let's go ahead and resolve the next operation, leftmost division. Let's go with 32 divided by 2 is, of course, 16 plus 2 times 2. Next, tackle that this last multiplication next. 2 times 2 is 4, so we got 16 plus 4. And to finish it off, 16 plus 4 is in fact 20. So that's the answer we get when working on this example. Let's move on. Next, we're going to talk about what to do with nested parentheticals. So that's parentheticals inside of parentheticals. Just a quick note. Sometimes you may see brackets on the outermost parentheticals. It's going to be the same situation. Basically, treat brackets like parentheticals. Real simple rule here. We're just going to work from the in out. So we're going to start with the innermost parenthetical and work our way to the outside. So let's begin. So the innermost parenthetical is 6 divided by 2. Let's go ahead and resolve that operation. So we're going to get 8, 3 minus 2, plus 3 when we do that operation. Okay, next we have a string of addition and subtraction. We know we need to work that from left to right, so let's go ahead and do it. Start with the leftmost subtraction. We're going to get 8 times inside the parentheses 1 plus 3. Okay, now let's tackle that other innermost parenthetical, this 1 plus 3 here. We've already resolved that one, so let's go to the next one. 1 plus 3 is 4. We get 8 times 4, and 8 times 4 is, of course, 32. So that's all there is to nested parentheticals. Let's move on to another example. Okay, so just some quirks with exponentiation and division. So sometimes you'll see like an exponent raised to, in the superscript, a string of operations. And we want to treat that as like 2 to the parenthetical of whatever that string of operations is. And that's because it is the argument of the exponentiation. So technically, probably as mathematicians, we should be writing it as that to be super clear. But when we have a string of operations in the superscript, just remember we're just treating that like we need to do that particular string of operations first. Because you might say, well, but Nathan, according to what you say, we should do exponentiation first. So shouldn't we do 2 squared and then add 3 to get 7? And this is wrong. What we need to do is actually add the 2 and the 3 first, which we should get 2 to the 5, which is 32. And this is the right way to do it. Kind of a little bit Not to be, you might not expect this, but this is in fact the correct way to look at this. Alright, so here we are back with division. And like we saw with exponentiation, when you see division written like this, we're going to treat these as arguments of the division. So this is an argument of our divisor. And this is the argument relating to the dividend. So we're going to want to do these string of operations if we have them first. We're going to do this string of operations if we have them first before doing the actual division. So like we've seen before, you might think, well, let's look at our PEMDAS acronym. You might say, well, okay, Nathan, but shouldn't we do our division and multiplication first? So shouldn't we do like 3 times 20? We get, for example, 60 over 6 plus 4. And then do our next division, which is 60 divided by 6. So wouldn't this be 10 plus 4, which is equal to 14? And this is actually not what we want to do. We want to do these arguments first. So what this really looks like, we do 3 times 20 for our divisor, so that's 60, and then we want to do 6 plus 4 for our dividend, that's 10. 60 divided by 10 is 6, so this is actually the right way to do this particular problem. Okay, so just some more special rules with exponentiation. If we have these so-called power towers, we want to work top down. And so I've kind of written out what that is going to mean here. So if we have this expression 2 to the 2 cubed, what we want to do is the top part first, so 2 cubed, and then take that 2 to the whatever that's going to be. In this case, it's going to be 2 cubed is of course 8, so we get 2 to the 8. 2 to the 8 is going to be 256, so this is the right way to do this. This is just showing what the wrong way to do is. We don't want to do it this way, so if we did the bottom first, what would we get? Well, we get 4, and we have 4 cubed, and 4 cubed is 64. But this is not how we want to do it. We want to do it this way. Okay, so we've got one final example here where we're just going to kind of put everything that we've talked about together. And we're going to run through PEMDAS and tackle this in the order that it should be tackled. So, parentheticals. Do we have parentheticals? Yes, we do, right here and here. We're going to tackle the innermost parenthetical first. So, let's write this all out. 2 cubed times 3 plus 6 divided by 2 times 3 minus, so we're going to resolve this innermost parenthetical first. 1 plus 1 is 2, so we get 3 minus 2. We're going to tackle this parenthetical next. We're going to get 2 cubed times 3 plus 6 divided by 2 times, well, 3 minus 2 is 1, so we get 2 times 1. Next we're going to look for exponentiation. I have an exponentiation right here. 2 cubed is 8. So we get 8 times 3 plus 6 divided by 2 times 1. Move on to multiplication and division. So we're going to work at the leftmost side and come our way to the right. So the leftmost multiplication is 8 times 3. We get 24 plus 6 divided by 2 times 1. The next leftmost division in this case is 6 divided by 2, so we're going to go there next. We get 24 plus 6 divided by 2 is 3. 3 times 1. The final multiplication is 3 times 1. That's just 3. So we get 24 plus 3, and our final answer is 27. I'm going to leave a challenge problem on the board for you to try. Take a look in the description for the answer, and have a great day.